This video is brought to you by Nebula, where you can get 40% off our yearly subscription by clicking the link in the description. Another incident involving the Boeing 737 MAX has added to its troubled reputation, with many calling it a cursed plane. On January 5, 2024, a serious mishap occurred when a door plug component in the fuselage of a 737 MAX 9 ripped off at 16,000 feet in the air. Over the weekend, searches for the missing door plug in Portland, Oregon, only recovered iPhones that miraculously survived the fall to the streets below. Fortunately, none of the 171 passengers or 6 crew members on board suffered serious injuries, partly because the seats next to the damaged fuselage were unoccupied. After the cabin lost pressure, the pilots quickly reduced altitude and performed an emergency landing back at the departure airport. So, what exactly happened to cause an entire panel of an aircraft to detach mid-flight? To understand this, we need to explore what a door plug is and how it functions on the Boeing 737 MAX 9. A door plug is a structural and cosmetic cover used to seal an unused door frame on the aircraft. When airlines purchase a 737 MAX 9, they have the option to configure it for higher passenger capacity by installing a functional emergency exit door. The number of passengers an aircraft can carry is tied to the number of emergency exits it has, as these exits are critical for safety evacuations. If an airline opts for lower occupancy, as Alaska Airlines did in this case, they can choose to install a door plug instead of a working door. The door plug is not a functional door but a panel that fills the doorway, blending seamlessly with the aircraft's interior and exterior. From the outside, door plugs are identifiable by their full-sized windows, unlike the smaller windows on actual doors. Inside the plane, the door plug is indistinguishable from other panels, allowing a standard row of seats to be placed in front of it. This configuration reduces the maximum occupancy of the 737 MAX 9 from 230 passengers to 189. If an airline later decides to increase capacity, perhaps to operate like a budget carrier such as Ryanair with tighter seat spacing, they can replace the door plug with a fully functional door. In this incident, it was the door plug that tore out of the aircraft, leaving a gaping hole in the fuselage. Photos of the aftermath are striking because the damage to the plane appears minimal despite the severity of the event. These stop pads, along with stop fittings on the door plug, showed little to no damage, which is surprising if the door had been forcibly blown off. The door plug is secured by hinges and straps that allow it to open at about a 15-degree angle during maintenance. Guide track roller pins at the top and bottom corners slide into guide tracks in the door frame, where they are locked in place by bolts one in each guide track. For the door plug to detach, it would need to move downward past these locking bolts, which suggests a failure in the fastening system. The missing door plug was recovered on Monday, 3 days after the incident, and it appeared to be in remarkably good condition. This observation points to a potential issue with the fasteners securing the plug to the aircraft. Either the fasteners fractured, were incorrectly installed, or were missing entirely. Early reports from industry insiders indicate that United and Alaska Airlines discovered improperly tightened fasteners on several aircraft, which could explain the clean breaks observed in the stop pads and fittings. If the bolts were under-tightened, used incorrectly, or omitted, the door plug could have dislodged under the stress of repeated pressurization cycles. Determining who is at fault is complex, and it's too early to assign definitive blame, but multiple parties could share responsibility. Boeing does not manufacture the door plugs or fuselages itself. These components are produced by Spirit Aerosystems in Wichita, Kansas, and then shipped by train to Boeing's facility in Seattle, Washington for final assembly. During the assembly process, door plugs are typically not fully secured because Boeing removes them to install the aircraft's interior for the customer. After the interior is installed, the door plugs are reinstalled and fully secured. This process, involving 2 separate companies, introduces opportunities for miscommunication or errors. For instance, if a door plug was delivered in a semi-secured state and not properly reinstalled, the oversight could go unnoticed. This is a plausible theory, though speculative as it aligns with Murphy's Law. If something can go wrong, it will. Alternatively, it's possible that the bolts were not fully secured across multiple aircraft, though this seems less likely given the quality control measures in place. Boeing conducts a safety check by pressurizing the aircraft's hull to 150% of typical air pressure before delivery. This test should, in theory, reveal issues with improperly secured door plugs. However, because air pressure pushes the door plug against the stop pads, semi-secured bolts might hold during the test but loosen over time due to vibrations during flight. To prevent this, a wire tie is used to stop the fastener from rotating loose, and other methods like locking washers or adhesives can also be employed. If these measures were not properly implemented, it could explain the failure. Alaska Airlines may also bear some responsibility. According to the initial National Transportation Safety Board report, the aircraft in question had experienced 3 pressurization issues in the weeks leading up to the incident on December 7th, January 3rd, and January 4th. In each case, the pilots took action, but the maintenance crew reportedly reset the pressure warning lights without investigating potential pressure leaks, which could have been caused by the faulty door plug. Alaska Airlines was aware of the issue and limited the aircraft's operations over open water to ensure emergency landing options were available in case of a larger problem. This decision suggests they knew something was wrong but may not have taken sufficient action to address it. The regulations that allowed the airline to reset warning lights without thorough checks could also be scrutinized, as this incident could have easily resulted in fatalities. The rapid depressurization posed a significant risk, and it's fortunate that no passengers near the door plug were pulled out of the aircraft. While this incident has drawn attention to Alaska Airlines maintenance practices, much of the public's focus has been on Boeing, given the 737 MAX's troubled history. The aircraft has faced significant scrutiny since 2 fatal crashes involving its earlier models. These crashes were linked to a software system called MCAS, implemented to compensate for instability caused by the installation of larger, more efficient, high-bypass engines. The 737's low ground clearance made it challenging to fit these engines without lengthening the landing gear, so Boeing mounted them higher on the wing, which altered the aircraft's stability and caused a tendency to pitch upward. Instead of redesigning the airframe, a costly and time-consuming process that would have required recertification and pilot retraining, Boeing opted for the MCAS software to automatically adjust the control surfaces. Malfunctions in this system led to 2 crashes, Ethiopian Airlines Flight 302 and Lion Air Flight 610. Which together killed 346 people. These incidents significantly damaged Boeing's reputation, revealing a pattern of prioritizing cost savings over safety. The door plug incident, while less severe, has reinforced perceptions of systemic issues within the company. For example, Boeing recently requested an exemption from a Federal Aviation Administration safety regulation for the 737 MAX 7 to address an overheating issue with the engine's composite cowlings. The company proposed limiting the use of the anti-icing system to 5 minutes in dry conditions to prevent the inlets from overheating and potentially fracturing, which could lead to debris striking the aircraft and causing decompression. This issue echoes a 2018 incident involving a 737 NG, where a fractured engine cowling caused a passenger's death after she was partially ejected from the plane. A representative from American Airlines Pilots Union criticized the exemption request, arguing that relying on pilots' memory to limit anti-icing system use was inadequate and that better solutions were needed.